Hi there, my name's Matt Leward and this is another early look at my current game project called the Eldritch Zookeeper, in which the player runs a cursed zoo badly. This time I've been concentrating on the tricky issue of pathfinding, that is, having AI actors navigate the world in a sensible manner and avoiding obstacles. Now, when I've had to implement similar behaviour in the past, I've gone for a simple grid-style system where some grid cells are obstacles and then I slap an A-star algorithm on top to find a route. It was clear from the beginning that it would be naive to assume that would work for this game because the world size is rather large. Storing that many nodes in memory would be a silly overhead to introduce in terms of the memory required, but it would also be computationally expensive as it iterated over so many nodes. I decided to experiment with a Navmesh approach, which starts from a similar concept as the grid-based one. You have a bunch of cells, some of them are described as collisions, but from this a series of points can be identified as the boundaries of these collision areas. Then, and this is where we must delve into the territory of computational geometry, a Voronoi diagram is generated, which is the stepping stone to calculating a Delaunay triangulation of all the points. The mesh that we get can then be said to describe all the walkable areas, and all the points are our nodes that the A-star algorithm iterates over. Actually working out the path from one position to another is rather speedy, perhaps only a couple of milliseconds at most, since so few nodes are required. What's very expensive, however, is generating the Voronoi diagram and the following Delaunay triangulation. That can actually take 2 or 3 frames to do, which is rather frustrating as the player can build fences at any moment, forcing a recalculation. To get around this, the world is segmented into sections and each section's navmesh can be recalculated independently from the rest, which is far more efficient. To keep the game running at a fancy 60 frames a second, pathing and navmesh calculation is all pushed into background threads, because if there's one thing that makes complex code simpler, it's threading. It has all been worth it, though. This is a rather large zoo with lots of fences and 100 visitors all pathing around, and it's performing rather well. It's not perfect, but it's certainly good enough for now. If you want to stay in touch as development continues, you can subscribe to the channel, but you can also follow me on Twitter at Matt Leward, and if you really want to support development, you can buy my previous game, The Cat Machine. It's on my site, cranktrain.com. It's also on Steam. See you next time.